this video, we're going to go over where point-slope form of the equation for a line comes from. And really, we're going to understand what it does for us. So it's going to be a short video, but an important one, so that we're not just using point-slope form randomly and not understanding what we're doing. Okay, so point-slope form is a different form for the equation of a line. So we've already had slope-intercept form. Point-slope form is a different tool for basically getting the same result, a line, to be able to be graphed or described. It's just a different way of doing it. So y minus y1 is equal to m times x minus x1, where m is the slope of a line, and x1 comma y1 is a point on the graph of a line. So again, a different tool for use of finding equations of lines. So let's rock and roll with where this thing comes from and why it works. And I'm going to show you algebraically first, and then I'm going to show you on the graph why it makes sense. Alrighty, so algebraically, where does it come from? Well, a couple ways we can show it. One way, and the way that I prefer to show it, is this. You've got that the slope equation of a line is y2 minus y1 over x2 minus x1, where y2 and x2 and y1 and x1 are each coordinates for points on a line. However, what we're going to do is we're going to say, let's let x2 and y2 be any point on the curve, not just a specific one that we call x2, y2. So that'll be y and x. That way these can take on many different values. And when we have that little 1 right there, that means that, well, x1 and y1 are set values, and x and y, well, they can move around all around on the graph. And I'll show you that graphically in a little bit. So why is this important? Well, let's take a look at the equation and what we have. We have slope is equal to y minus y1 over x minus x1. Now what we're going to do is we're actually going to solve for y minus y1. To do that, we'll multiply both sides by x minus x1. And that's the entire grouping right there. That's to undo what we're dividing by here. That gets y minus y1 alone. So these quantities divide out completely, and you're left with, well, I'm going to bring the y minus y1 to the left of the equation, no sweat. And I'm going to bring this side over to the right side. That'll be m times x minus x1. I just switched the order of multiplication, m times x minus x1. And what do we have? A line. Very nice, and it's the point-slope form. So that's where it comes from algebraically. What does it mean graphically? Well, this might help to make a little more sense. Let's just pick a random point. I don't know where the point is. Let's just put it right there. We'll call that point x1, y1. That one's fixed. And then we have another point anywhere else on the graph. Let's put it here. Now that point is a point on a line that can move. What I mean by that is x1, y1 is fixed. That can't move. But this point, x comma y, can go anywhere that it wants to, right? It can shift down, up, anywhere that you want. So we already know what the slope of this thing's going to be. It's going to be y minus y1 over x minus x1. But let's take out a look a little bit differently. So let's say that we already know what our slope is. Let's say that the slope is m. That's how fast that we're moving on this line, right? The rate of change. So the change in y, how much difference we have in the y values, we know is y minus y1. Well, how do we figure out how much we've risen? Well, we take how far we've run, which is x minus x1, and if I multiply how far I've run by how fast I'm running, well, rising over running, I will get how high that I've climbed or how much I've risen. And I'm going to put this in a simpler term. Let's say that this is time, and let's say 2 hours have gone by, and we are, I don't know, traveling at a slope of 60 miles an hour. Well, if this is hour, let's say 3 and hour 1, 3 minus 1 would give us the 2 hours we've traveled. M is 60 miles an hour. If I multiply 60 by the 2, the change in the time, that gives us 120 miles, which is how far we've risen. And so that would give us the next point on our line. Pretty cool. It's heavy stuff. So I don't think point slope form is for the faint of heart in terms of really understanding it. You might need to chew on it a little bit, really think about it, but at least understand that it comes from slope and solving the slope equation for y minus y1. So you're basically saying how much y has changed. It's your rise is equal to slope is rise over run times run. That's another way of looking at it. That's it, peeps. A little bit of an abstract but conceptual way of understanding point slope form and where it comes from. In later videos, we're going to go over how to use this thing. Let's do it.